Okay, so if you haven't already, we know this is 0 degrees, this is 90, and this is 180. Okay, and then the first one on our unit circle is 30. So we're going to take our equiangular ruler, and we are going to set the center at the center of the circle, and I'm going to use a pencil. So the center of your circle should be where you put the vertex of your angle. And then I'm going to label that as 30 degrees. So I'm just going to label it right on the line. After 30 degrees, chronologically, what's the next angle? 45. Okay, so the 45 one's going to come next. And then, yep, after that, you are going to do the 60. Okay, so you are going to have to adjust so that you always have your vertex in the center. Okay, and then again, we are going to label those. So this was 45 degrees and this was 60 degrees. Okay, and I'm going to be color coding mine. Okay, so now what we're going to do, once we have the first quadrant, which I just use quadrant. Do you guys remember what all of your quadrants are? So the first quadrant is going to be here, okay, where the x and y axes are positive, and then we go counterclockwise. So this is quadrant 2, this is quadrant 3, and this is quadrant 4. So now we're going to extend all of the lines from quadrant 1 to quadrant 3. So I'm going to take my 30-degree line and I'm just going to extend that. Same thing with my 45. Same thing with my 60. Now think about their relationship in the circle. If this is a straight line is how many degrees? 180. So if this is 30 degrees, this is just 180 away from 30, which would make it what? 210. Now I could keep adding 180 every time, but let's start to notice some special relationships here. So it goes 0, 30, 45, 60, 90. So in between these two angles, 30 to 45 and 45 to 60, how much degree space is between them? 15. Okay, and then I have 0 to 30 and 60 to 90. How much degree space is between those? 30, right? Okay, so if I wanted, I could just add how much to 210? 15. So 210 plus 15 would be 225. And then what would I add to get here? Okay, 15, which would be 240. And then if I wanted to do this one, how much would I add? 30, which would be 270. Okay, so then what we're going to do is we are going to make the 30, 45, and 60 angles, but in quadrant 2, and then we're going to extend them to quadrant 4. Okay, so I'm going to give you some time to do that right now. So now what we're going to do is we're going to be going the opposite way that we were before, but we're still using the same measures. So the distance from any axis to that first angle is going to be 30 degrees. And then you'll have the 45-degree angle, and then you will have the 60-degree angle. Okay, and then again we are going to extend these into the fourth quadrant. Okay, and then again you can just follow the pattern. So if you want to keep adding, you have the 30, then add the 15, then the 15. Okay, and go ahead and do that all the way around until you get the full way, which the full circle is going to be 360 degrees. Okay, and then after you guys finish the degrees, we're going to start moving on to radians. Do you guys know what radians measure? Dennis, put that away. What do radians measure?
The distance on the arc.
Okay, yeah. So it's what do degrees measure? What do radians measure?
The arc of the angle.
They measure the same thing. So it's like when you're measuring temperature, right? You can measure temperature in Celsius or in degrees Fahrenheit. Angles, you can measure in degrees or you can measure them in radians. Okay, so they do have a special relationship. Even if you weren't sure how to do the conversion, you can always use a proportion. So first, the radius of the unit circle. Do you guys remember what the radius is? No. Yeah, the radius is 1. What's 2 pi? The circumference. Because the circumference, yeah, is 2 pi r, and if our r is 1, 2 pi times 1 is just going to be 2 pi. Okay, which is why when we're writing down our radians, you would start at 0 radians. A full time around the circle would be 2 pi radians, which remember circumference is the distance around the circle. Okay, and then here, half of this would be what? Pi. Okay, so I know some of you probably already have the first quadrant memorized. I'm just going to show you where it comes from. Okay, and then 90 degrees is halfway between 0 and pi. So in radians, we would call this what? Pi over 2. And then really, half of a half is what? A quarter, right? So could you guys pick out where the quarter is here? At 45, right? I made a little wedge earlier. So like a fourth, 45, 45, 45. Okay, so then this would be your pi over 4. Okay, now for 30 degrees and 60 degrees, I want you to think of it like this. Okay, this is 30 degrees of the top half of the circle. So if you did 30 degrees over 180 and you reduced it, you could divide divide by 10, and then 3 over 18 is going to be what? 1/6. Okay, so because we're talking about radians, it'll be 1/6 times pi, or pi over 6. So that's why 30 degrees is pi over 6. It's a ratio. So with 60 degrees, I could do something similar, right? 60 over 180 is going to reduce to what? 1/3. So this would be 1/3 pi, or pi over 3. So you have pi over 2, and then pi over 3, pi over 4, pi over 6. So it goes 2, 3, 4, 6 on the bottom. So sometimes people might think, oh, why doesn't it go 2, 3, 4, 5? Instead, it's because it's not the ratio. So this is 1/6 of the top hemisphere. Okay, now like I said, you can find every single radian just from knowing this first quadrant. Okay, and it's going to be counting. So you're going to have to pay attention first, and then I'll give you time to fill each radian slot in. So with the first one, let's say I wanted to count by pi over 2. Pi over 2 represents how many degrees? 90 degrees. Okay, so every 90 degrees is where I'm going to count. So I start here at 0, and then this would be 1 pi over 2. If I go another 90 degrees, I'd be at 2 pi over 2. What is 2 pi over 2 reduced to? Pi. If I go another 90 degrees, I'd be at 3 pi over 2. And if I go another 90 degrees, I'd be at 4 pi over 2, which reduces to 2 pi. Okay, now we're going to do the same thing with the quarters. So the quarters are how many degrees? Okay, so this would be 1 pi over 4. And then, Sam, at what degree is 2 pi over 4 going to be? So pi over 4 is how many degrees?
Pi over 4 is 45 degrees.
Okay, so 2 pi over 4 would be at?
It's just going to be, pi over 4 is going to be 1/2 pi, basically, so it's going to be, wouldn't that just be 90 then?
Yeah, so you're going to keep counting the 45 degrees. So this will be 1 pi over 4. You go 45 degrees, 2 pi over 4. I'm going to go another 45 degrees, which is going to be where? At 135, and that's going to be what? 3 pi over 4. I'm going to go another 45 degrees, which will be 4 pi over 4, which already reduces. And then do you guys think you can fill in the rest of the over 4s? Okay, so we had 4 pi over 4, so this is 5 pi over 4. 6 pi over 4 reduces, and then we have 7 pi over 4. Okay, now the only one we have to do next is the 30 degree, because if you add 30 to 30, what do you get? 60, so they'll hit all the same spots. Okay, I'm going to show you on here real quick what it is, and then I'll give you time to do it. Okay, so make sure you're paying attention. So this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. So each time I moved my finger, how many degrees did I go? 30, because I was counting by pi over 6. If I was counting by pi over 3, how many degrees would I go? 60. I'd go 60. So I could do that if I wanted. So this would be 60 degrees. If I went another 60 degrees, where would I be? 120. So if this was pi over 3, this would be 2 pi over 3. Now I said you could use the over 6 because that's going to hit those. You're just going to have to do what with the fractions? Reduce them. Okay, so this was 1 pi over 6, 2 pi over 6, 3 pi over 6, which reduces, 4 pi over 6, which reduces. 5 pi over 6. And then don't skip the whole ones. Usually that's, when people are counting, that's something you can mess up on. So 6 pi over 6, that reduces. 7 pi over 6. 8 pi over 6. What does 8 pi over 6 reduce to? 4 over 3. Okay, and then I want you to notice something else. Look at these reflections. Pi over 3, 2 pi over 3, 4 pi over 3. What did this one end up being? 5 pi over 3, right? So if the line is reflected, they're going to have the same what? Denominator. So if you reflect pi over 4, see how all the denominators are 4? If you reflect pi over 6, see how all the denominators are 6? This would be 11 pi over 6. Do you guys notice that? Okay. Okay, so that's going to be your radians. And then the last thing we're going to talk about today are your points. Okay, now each quadrant here is going to have certain signs for X and Y. Okay, so if you are in quadrant 1, so like I said, think of this as Y and this is your X. The X values in quadrant 1 are always what? Positive. The Y values in quadrant 1 are always positive. Okay, so you have a positive X value and you have a positive Y value. Let's look and see how that changes in quadrant 2. So in quadrant 2, what part of the x-axis am I on? The negative. What part of the y-axis am I on? The positive. Okay, so the x was negative. The y was positive. Okay, for quadrant 3, what part of the x am I on? Negative. Y? Negative. Okay, and then for the 4th quadrant, what part of the x am I on? Positive, and the y? Negative. So my x is positive, my y is negative. Okay, so earlier today we talked about the special triangles and how those are related to each one of these lines. So now we can put in our special points. So we talked about how if this was 30 degrees, your x value was root 3 over 2, your y value was 1/2. For 45 degrees, it was root 2 over 2, root 2 over 2. And for 60 degrees, it was 1/2, root 3 over 2. Now remember that the radius of the unit circle is 1. So if the radius is 1, what is this point going to be? 1. Comma.
0.
Yeah, 1, 0, right? At the top, I'd be where?
0, 1.
0, 1. Here I would be?
-1, 0.
-1, 0. And here I would be 0, -1. Okay, so I want you to notice a couple of cool things about how these patterns work. Because usually people remember this one pretty easily, but it's easy to get these two confused because they have the same numbers, right? Okay, so maybe you guys have seen this trick, but first, what are all the denominators? 2. And then see how this starts at 0? So look, it goes 0, 1, 2, 3. Okay, so you can always think of it as the square root over 2. Because the square root of 0 over 2 is just 0. The square root of 1 over 2 is just 1/2. And then you have the square root of 2 and the square root of 3. but it's easy to think of it as 0, 1, 2, 3. Just remember the 2 and 3 are going to have the roots on them. Okay, and then so from the 1, it would go root 3, root 2, 1, 0. Okay, so it goes up from 0, it goes down from 1. Cool? Don't act like you're not impressed. Okay, so like I said, the first quadrant is going to be all you need to know, and you'll be able to fill in everything else. And that's because you can use reflections. So if I reflect this point into quadrant 2, if I do a reflection over the y-axis, this point here I know is still 1/2 root 3 over 2. The only adjustment I have to make is on the sign. So the x value is now negative. Okay, then I'm going to put my x value as negative. I'll do the same reflection. Okay, so if I do a reflection now over x, I'm here at 240. So again, my point is 1/2 root 3 over 2. But now I'm in the third quadrant where both points are negative. So I'm going to make both of them negative. And then I'm going to go ahead and reflect again. So again, I have 1/2 root 3 over 2. And this is where my x is positive and my y is negative. So there you go. Okay, so you can do that with all of your points. Okay, and I'll give you some time to do that in just a second. I also just want to review with you how these are related to your trig functions. So every single point is actually given in terms of the cosine of theta and the sine of theta. Do we remember that? So the cosine is equivalent to your x coordinate. Your sine is equivalent to your y. And then there's a few special things that you can tell from your quadrants. Okay, and one of these special things is you can tell where the trig functions and their reciprocals. Do you guys remember the reciprocals? Are positive. Do you guys remember the little acronym? All students take classes, or all students take calculus? Maybe that's new. Okay, so the all means that all the trig functions are positive in quadrant 1. Okay, so your sine, your cosine, your tangent, and their reciprocals. Okay, so the cosecant, secant, and cotangent. In quadrant 2, so this is quadrant 1, in quadrant 2, it's the sine that's positive, which makes sense because the sine is the y, that's where the y is positive. In quadrant 3, the tangent is positive. And in quadrant 4, the cosine is positive. So all students take classes. Okay, and remember that our points are cosine and sine, but we can find the tangent by doing what? Yep, sine over cosine. So it's the sine of theta over the cosine of theta. So these are my thetas. Okay, or you could also think of it as your y over x. Okay, so that's something that we're going to be extending tomorrow. Okay, so all you need to do on this is to finish those points. Okay, so finish filling in those points.